God, parang kidlat. Hello guys, and come back. And now let's go to another topic in thermodynamics, which is very helpful to understand how to solve problem solving in thermodynamics. Okay, especially the first one, the second law, right, of thermodynamics. Not so much with the third law of thermodynamics and the zero law of thermodynamics. This is very unique, right, because thermodynamics have zero law. Okay, zero law of thermodynamics, it talks about thermal equilibrium of the system. Okay, like that. So it's mainly on the conduction. Okay, the heat transfer to conduction. For example, if you have coffee like that, very hot coffee, and then suddenly you will stand that for 2 minutes or 3 minutes in the table, it will become cold. So the heat will be released, okay, and then it will become cold suddenly. Okay, there is a heat removal process. So meaning the heat is being transferred to the environment, okay, because it receives also the heat of the AC, which is the negative heat, okay, the cool, COOL, the cooling effect. Because in thermodynamics class, the heat is not only focusing on the positive heat. We have also negative heat, which is the cold, or the COOL. Okay, it should be plus and minus. Okay, because what our idea is, if it is hot, it's already hot, but it's not no longer obeying the heat formula, but still it follows the heat formula because that is endothermic environment, something like that. Okay, negative, cool, cold environment, something like that in the zero law of thermodynamics. I discussed that yesterday, right, in detail. Okay, in the third law of thermodynamics also. So don't forget the Nernst, Nernst, Simon theorem and postulates, because he is the one who discovered that a perfectly crystalline solid at absolute zero, the entropy of this perfectly crystalline solid is always equal to zero. Okay, that's his discovery. Maybe it will come out also in the board examination or repetitive examinations. Okay, then there will be a lot of choices, something like that. Okay, Nernst, Simon. Okay, that's why it's called Nernst Simon postulate. Okay, or theory or theorem. Okay, or a scientific discovery, something like that. Okay, so that's credited to him. The third law of thermodynamics. Okay, still entropy is discussed there. Okay, but the main discussion of the entropy introduction is in the second law of thermodynamics. Okay, not on the third law of thermodynamics. Okay, but in the first law, it's not yet tackled the entropy of the system. Okay, it's purely on the heat energy, internal energy, and the work done in the system. Okay, now going back to the latent heat of condensation. Ganun ba? Yes. First, what is a condensation? In our chemistry in high school, right? We memorize this a lot of shun, right? So condensation, sublimation, solidification, filtration, solidification, eutrophication, filtration, crystallization, sedimentation, flotation, so many, right? A lot of shun. So I hope you memorize all those physical and chemical processes, because it will help you a lot to pass science examination, especially in theories and concepts. Okay, now going back to condensation, this is a change from, if we have liquid to gas, this is the reverse. Okay, a change from gas to liquid. Okay, through the process of condensation. Okay, so latent heat of condensation. See, even though this is also a condensation, heat also is there. Latent heat of condensation, or heat of condensation, is just the same. Okay, latent heat of condensation. Condensed milk. So we need to say it involves the process of condensation before it will become a milk. That's why it's called condensed milk. Okay, latent heat of condensation. Ganun siya. Okay, heat of condensation. Okay. So, ganun, condensation. Latent heat of condensation. Okay. Guys, the latent heat of condensation, if we speak about the value of the constant, is just the same with the latent heat of vaporization, but it is the reverse, the negative sign. Okay? If we have 2,260 kilojoules per kilogram as our latent heat of vaporization, then our latent heat of condensation is equals to negative 2,260 kilojoules per kilogram and negative 40.8 kilojoules per mole. It's very easy to recall because it's always the negative of the latent heat of vaporization because of the fact that the process is the reverse of evaporation. Right? This is a very logic reason for that, valid reason. Because condensation is the reverse of the evaporation, then of course, the value of the constant also will be the reverse. If you have the positive, then the value also is negative. Okay. Like that, okay? So, the definition will be different. The reverse also, the definition. Oh my gosh. Hello guys. Hello guys. Okay. The definition also will be the reverse. Okay, this is the heat released of 1 mole of a gas, like this. This is the reverse. Okay, it's the heat released of 1 mole of a gas that is condensed at 100 degrees Celsius at a standard pressure. It looks like complicated, right? But you just understand to make it clear. Okay, so the clue there is at standard pressure, mahitabo ang latent heat of condensation. And then also, the temperature is 100 degrees Celsius. And then also, there's a 1 mole of the gas substance. Okay? And then there's also a heat release. Then combine it all and put that in one paragraph. That will be your definition. It's gonna be like that understanding, okay? Not just purely memorizing, okay? So the latent heat of condensation is the heat release of a 1 mole of a gas substance, okay, that will be condensed at 100 degrees Celsius at standard pressure. So that is latent heat of condensation. The word condensed there is very important at 100 degrees Celsius at a standard pressure. The Sotero one is a standard pressure. At STP, if you can remember that one, what is the pressure? That is 1 atmosphere. Something like that, okay? So that is for the latent heat condensation. It's the reverse. Now, if it is the reverse, if you will try to substitute that in our first law of formulas, the heat, delta U, change energy plus W, then the answer also will be the negative energies. Okay. Now, it's in here that we give emphasis to the signs. Okay, now let's go first with the, oh my gosh, let's go first with the, the heat. Okay, or the enthalpy. Okay. Enthalpy or heat, pariwari gina siya ha, pero yun yung nabanabanahan. Okay, heat and delta H. Okay. English. Okay. Heat. Okay. Heat is added to the system. Okay, this is the first terminology. Heat is added to the system. Okay. Heat is absorbed to the system. Heat is consumed to the system. Okay? So that is a positive heat and a positive enthalpy. Okay? These three words, it is being mentioned in the problem solving. So heat is added. Okay? Heat is consumed. Heat is absorbed. Okay? Now, if we try to put that in a system and in a surrounding, the system is inside the surrounding or in the environment. So if it also states that heat released from surrounding, so your heat also is positive because that's from surrounding, it's not on the system. Maybe you will be also confused because heat release is only for the extra. No, it's not, because the word from, English, from the surrounding. So it will be released to the system. So that's still positive. Even though the word release is being put in the in the term, in the statement, but still it's positive because of from the surrounding, not the system. Okay, so it's gonna be like this, the confusion of some students, including me before. So I have to tell the truth. Okay, something like that. Okay, now I will say also heat given off from the surrounding. That's still heat positive because it is being given to the system that's within the surrounding. Okay, but never mind. That's not as complicated as it was in, it will be reflected in the problem solving. It will just say heat removed to the system, like that only. Heat is absorbed or consumed, not the other one. Will not be the basis of the surrounding, but always on the system alone. But we don't know if they try to trick you out and confuse you out using the surrounding like that. Okay, for example, 200 joules of heat released from the surrounding. Okay, because you are used to that the release is negative, right? But it is positive because that's from the surrounding. It's not released to the system. Like that. Okay? Okay, you got the point. Okay? So like that. Okay, so heat is positive. It means it is being added to the system. Okay? Consumed to the system. Absorbed to the system. Heat and enthalpy will be positive. Heat and enthalpy will be negative if it is being released, okay, from the system. Okay, released from the system, okay, removed from the system, given off from the system, okay, and exposed from the system. Or it could be to the surrounding na siya. Okay, so heat released to the surrounding, heat given off to the surrounding, okay, heat exposed to the surrounding. So the clue there is the from and the to words. It's very important also. From and to. Okay? So from meaning the reference, and to where it is being transferred to the final destination. Something like that. So it matters. Okay? So be careful also for the sign. Okay? Like that. That's for the heat. Now, so where can we see that's endothermic? Of course, if it is really on the absorbed, okay? Because if it is being absorbed, and then the environment will become cold man shot, so that is endothermic. Okay? Right? So that means we are referring to the surrounding. If we are trying to use the word exothermic and endothermic, we are not referring to the system. We are referring to the surrounding or the environment, what will happen. Okay, so ano naman siya, heat is being absorbed, okay, from the surrounding, or heat is being consumed from the surrounding. So that is endothermic reaction or endothermic environment. So the environment will become cold because the heat is being absorbed sa system, not man sa surrounding. Okay, so that's become endothermic. And the reverse will also for the exothermic. Okay, like that. Sometimes it can create confusion, right? Okay, the surrounding and the system. It's gonna be like this in physical chemistry kasi. Okay, isolated system, open system, closed system, ganun siya. Okay, especially the entropy. Okay, like that. Okay. Now for the word. Okay, the word class, positive and minus. Be careful also for the terms. If we say work done by the system. Okay, it is positive or negative? It is negative because you let the work done by its own, so it loses the energy by the system. Because by the system. Okay, that's negative work. But if you will say work done on the system, that is positive because it is being on the system. So it's not loses the work, okay, or the energy. Again, work done by the system is a negative word, and work done on the system is a positive word. And you need to account the sign. It's very important in thermodynamics, okay? So positive and minus, because your answer will be wrong. It's very far from negative to positive, right? And sometimes the churches also have negative and positive somewhere along the way. A, 200, positive 200 joules. B, be negative 200 joules. And then you compute that in the formula, you get the exact value, but only the sign. So this matters the most. The theory will matters the most in that. Okay? Because you get only the numerical figure, man. Okay? So it is negative or positive, something like that. Just if you try to correlate this in physics, it should be vector quantity that matters the most in the sign. Vector quantity, not the scalar quantity. But in here also, it's the the positive and minus positive. It depends on the system and the surrounding relationship. Okay, so plus and minus. Okay, plus and minus also. Plus and minus also. Ganun siya. Okay? Ako bang balikon or dili na siya? Okay, balikon ako. So work done by the system is negative. Work done on the system is positive. Okay, heat released. Okay, heat given up is negative. Okay, and then heat absorbed, heat added, and heat being added. Okay, added and absorbed is just the same in this context, and absorbed. Okay, so we are referring all to the system, ha? Just forget the surrounding muna. Okay, system lang yun siya. Okay, so that's our basis for the signing here. Because sometimes in chemistry, reverse man good siya. Because sometimes in chemistry, more on the surrounding. Okay? Like that, the chemical reaction, like that. So what will happen in the surrounding? Ganun siya eh. Especially the combustion reaction, it will give off carbon dioxide and H2O. In the surrounding, man good siya. Okay? Muna siyang reverse food ang chemistry. Okay? But more referring to the surrounding, man good siya. Especially the chemical reaction. If this is the system in the laboratory, this is your system, you add methane to oxygen, that is your system inside the laboratory, then your product will be exposing man good siya sa environment or the surrounding. That's why your reference there will be the surrounding not the system. Something like that, okay? But forget that a little bit. Okay, just focus on the system here in the thermodynamics, okay? Like that. Okay, that is for the sign effect, chuba. Okay, thank you so much. If you really understand a bit for this discussion, then you can comment down below in the comment section. And if you're not subscribing with my YT channel, then you can subscribe now if you want. And then you can also click the notification bell for some news updates and see your channel voice. Bye bye. God bless everybody. Okay, see you later. Oh my gosh. Char.